So now, without further ado, I'm going to hand it over to Paul again to introduce our speaker, Mike Clancy. Paul.
Thank you very much, President Jennifer. Mike Clancy earned a Bachelor of Science in Oceanography from the Florida Institute of Technology and a Master's in Meteorology from the University of Miami. He worked for Science Applications International Corporation in the late 70s and the Naval Research Lab in the early 1980s. He joined the U.S. Navy's Fleet Numerical Meteorology and Oceanography Center, FNMOC, in Monterey in 1983 and was selected as Technical and Scientific Director in 2005. Mr. Clancy has authored over 100 publications in meteorology, oceanography, and information technology, and received over 50 professional awards, including the Navy's highest civilian award, prior to his retirement from federal service in 2011. He was inducted into the FNMOC Hall of Fame in 2015. He is a member of the Monterey chapter of the Citizens Climate Lobby and a frequent public speaker on climate change. Welcome, Mike, and thank you for being with us today.
Oh, thanks so much, Paul. And I want to thank you as well as Jennifer for inviting me, and also Peter for helping me get set up for the talk here. I always love talking to Rotary clubs. I mentioned to Jennifer earlier that the founder of Citizens Climate Lobby, Marshall Saunders, was a Rotarian. And also there's a lot of overlap between climate change issues and your areas of focus, particularly your newest area of focus, supporting the environment. So good on all of you for that. I'm going to now share my screen and go to my slides. And if I could ask everyone to mute their microphones, please. If you have a question, you can unmute and raise that question with me, but hopefully there's going to be enough time for questions at the end here. So the title of the talk is Understanding and Mitigating Climate Change. And we'll jump right in here with, let's see, the first slide. Introduction and context. What I'm showing you here is a plot of global mean surface temperature of the Earth over the past 22,000 years. Now, global mean implies averaged over the entire face of the Earth, and surface temperature over the ocean is the sea surface temperature. Over the land is the temperature a few meters above the surface. And what you see here is the last ice age, recovery from the last ice age. This is called the Holocene warm period. Here's the beginning of human civilization about 9,000 years ago. This little bump here, which was from 900 to 1200 AD, is called the medieval warm period. This is called the Little Ice Age. That was from 1500 to 1700. And finally, we come to this red spike here, which in fact is the post-industrial global warming that we are concerned with. Now, the thing about it is the global warming of the past 120 years has been proceeding about 20 times faster and in the opposite direction of natural climate change. This is what natural climate change looks like. In fact, over the last 7,000 years, we've been cooling because of changes in orientation, the orbital variations of the Earth. And suddenly, beginning right with the commencement of the Industrial Revolution and the burning of large amounts of coal, suddenly we're warming about 20 times faster than natural climate change. Now I'm going to zoom in here on this red spike. And what we're looking at here is, again, the same parameter, global mean surface temperature of the Earth, but now plotted from 1850 to 2017 by year. The last chart was plotted by every 50 years, now by year, and you can see a lot more detail here. And we're looking at this from 5 different sources, 5 different independent, very credible sources, looking at 5 different data sets, 5 different ways of processing the data, but they all paint the same picture. And the picture is as follows: from 1850 to 1880, not much of a change, a slight decline from 1880 to 1910. Then pretty significant warming from 1910 to 1945, slight decline from 45 to 75. And then beginning in the mid-70s, a strong upward trend of temperature such that we are now running a little bit more than 1 degree centigrade above the pre-industrial era. Note that the temperature doesn't go up in a straight line. There are these zigs and zags here. These zigs and zags here are called climate variability. It's things like El Nino and La Nina produce those. But what really counts is the long-term trend, the 30-year or longer trend here. Now, I'm going to show you an animation of one of those data sets. In fact, it's the NASA data set. It's going to be from 1880 to 2018. And what we're going to be looking at is surface temperature anomaly. Now, temperature anomaly is just a fancy way of saying temperature difference from a reference field. And in this case, the reference field is the 1951 to 1980 30-year average. So where you see white on the chart, then the temperature is the same as that 30-year average. Where you see yellows to oranges, it's warmer. Where you see blues, it's cooler. And here's the temperature scale right here. The dark oranges are 2 degrees centigrade above that average, and the dark blues are 2 degrees centigrade below that average. Now, the years are going to flash by here. I'm going to call out the decades. You keep focused on the temperature changes here. Pay particular attention to what happens in the mid-70s, then we'll draw a few conclusions about that. So here we go. All right, so we're in the 1880s, 1890s, 1900s, 1910s, 1920s, 1930s, 1940s, 1950s, 1960s, 1970s, 1980s, 1990s, 2000s, and we end up at 2018. So what you can see is a couple of conclusions here. First of all, the land is warming faster than the sea, about twice as fast, even though about 95% of the heat of global warming is in fact going into the ocean. But in fact, the ocean is warming. That's for sure, all the yellows here. The farther you go north, the more it warms. That's called Arctic amplification. It's not warming everywhere. Notice there are some areas of blue here where it's actually cool during this period. That generally has to do with changes in ocean circulation. There's also a lot of variation over the land. Look how much we've warmed in the western United States compared with the eastern or the southeastern United States. And of course, with this warming has come drying, and we've experienced the effects of that very strongly in the last few years. So what's going on here? Well, in fact, it is the greenhouse effect. And the best way to talk about the greenhouse effect is in the context of the Earth's energy budget, which is depicted here, which shows the flows of energy over the Earth. Now, you might ask the question, what about other sources of heat here? What about heat from the interior of the Earth? Why isn't that on here? Well, it's because it's so very small compared to the flow of heat from the sun. In fact, all other sources of heat are negligibly small. Waste heat from buildings, forget it, negligibly small. All other sources of heat are negligibly small compared to what's depicted on this chart here. And so the greenhouse effect is pretty straightforward, and you're probably pretty familiar with it. Basically, incoming solar radiation warms the Earth. Reflected solar radiation, reflected from clouds and aerosols in the atmosphere, reflected from the surface, particularly snow and ice covered areas on the surface, as well as outgoing long wave radiation, that's also known as infrared radiation, that cools the Earth. And greenhouse gases in the atmosphere trap the outgoing long wave radiation and warm the lower atmosphere, emphasis on the word lower, the lower atmosphere and the surface of the Earth. And then finally, human activities increase greenhouse gases in the atmosphere and increase the warming. Now, the greenhouse gases, in order of how much they trap the heat, are water vapor, which we perceive as humidity in the atmosphere, carbon dioxide, methane, the fluorinated gases. These are gases that contain the atom fluorine in their molecule. They're typically things like refrigerants used in air conditioners and refrigerators. And finally, nitrous oxide. Note that I've colored water vapor differently from the others. That's because water vapor does not drive global warming. Water vapor contributes to global warming through the so-called water vapor feedback loop. Atmosphere is getting slowly more humid, but it does not drive global warming. And the reason why it does not drive global warming is water vapor is in balance with the natural hydrologic cycle. And it also has a very short residency time in the atmosphere. If you put a bunch of water vapor in the atmosphere, it's just going to rain out within about a week or two. And we're not putting lots of water vapor in the atmosphere. On the other hand, these other gases, these are the gases that do drive global warming. We are putting lots of these gases into the atmosphere. They are not in balance with any natural cycle. They're out of balance, and they are increasing dramatically. And that's what's causing the global warming and climate change we are concerned with. So what are the consequences of this global warming and climate change? Well, I like to divide them into two categories: natural consequences, that is consequences on the natural world, and then sort of geopolitical consequences. So I'm just going to hit the high points here. Increasing frequency and intensity of severe storms, heat waves, and cold snaps. Global warming doesn't, is not invalidated when you have a blizzard and a cold snap. That is in fact a symptom of what we expect from global warming, because it's making the atmosphere more unstable, and that makes blizzards more stronger. So it's not just the storms of summer, it's not just heat waves that are enhanced by global warming, it's also cold snaps and blizzards and so forth. Increasing frequency and intensity of floods in wet regions, increasing frequency of droughts and wildfires in dry regions, like the region where we live in. Generally speaking, wet areas get wetter, dry areas get drier. Decreasing mountain snowpacks and earlier snow melt, big issue for us here in California, since we get a lot of our water supply from the Sierra snowpack. Rising sea levels, increasing mortality of coral reefs, also known as coral bleaching, decreasing productivity of fisheries, increasing species migrations and extinctions with loss of biodiversity. There's about 8 million species of flora and fauna in the world, and about 1 million, which is about 12% of those, are under threat of extinction from climate change. Now, that's not just climate change. There are other issues too, such as human encroachment and so forth, but about 12% of species are under threat of extinction, and climate change is a big contributor to that. Okay. So here's a quick summary of some of the severe weather events that happened in 2021. Were in the news. Hundreds killed by floods on 3 different continents. The historic freeze, which shut down Texas. The first ever in history and first in recorded history rain occurred at the highest summit of Greenland. Hurricane Ida devastated Louisiana. Unprecedented, unbelievable heat wave killed hundreds of people in the Pacific Northwest last summer. Of course, we're in the middle of this historic drought, which has produced record wildfires and water shortages across the Western US. We're all living that. There was this extremely rare December tornado outbreak, which devastated Kentucky and produced the first ever in recorded history December tornado in Minnesota. And then just last week, we had the unprecedented storm and wildfire, which destroyed about 100 homes in Colorado in December, which was, an unprecedented event. So what are the human consequences of a warming world and climate change? Well, I'm just going to hit the high points. Increasing economic costs, increasing competition among nations for water and food, increasing displacements of people leading to unrest, increasing threats to human health, increasing human mortality from heat waves, floods, and other severe weather events, lack of food, lack of fresh water, disease, and war. And these risks are generally greater for disadvantaged people living on the edge, particularly, but not exclusively, in developing countries. So where are we going with all this? Well, back to the 22,000 year view here of global mean surface temperature of the Earth. This is where we are right now. Where are we going? Well, it depends on what we do, the people of the world. If we embrace the Paris Accord and make the reductions in greenhouse gas emissions that are called for in the Paris Accord, we would be able to hold the global warming by the end of this century to about 1.5 degrees centigrade above the pre-industrial, which is about here. If we ignore that, if we basically carry on business as usual and say, throw up our hands, we're just not going to try to deal with this at all, well, we're going way up here. That would be 4.5 degrees centigrade, plus or minus 1. And see how extreme that is. Here's the difference between an ice age and our current warm period, and this is comparable to that. It's incredibly extreme. Well, fortunately, we're not going up there. We're doing better than that, but not that much better. Right now, the world is on track for about 3 degrees centigrade of warming by the end of the century. That's twice what Paris said we really need to hold things to. It's about 3 times where we are right now. It's about twice what the Paris Accord says we need to hold the warming to. I personally think we're going to do better than this. I think we'll probably come in at about 2.5, which is right about here, which is very extreme, but at least it's better than what we're on track for right now. So what needs to be done? I'm a big fan of Project Drawdown, and you can visit our website at drawdown.org, and you'll find this document here, the Drawdown Review. Project Drawdown presents 82 solutions for reducing greenhouse gases and or by avoiding emissions or by sequestering carbon dioxide already in the atmosphere. These solutions consist of technologies, practices, and policies organized into 9 sectors and implemented into 2 scenarios. One is hold the warming to 2 degrees, and the other is hold it to 1.5 degrees. Those are the goals of the Paris Accord. Drawdown essentially provides a roadmap for stopping and eventually reversing global warming and climate change. And like I said, I'm a big fan of them. They have done a great job looking at it not just scientifically and technically, but also economically. They have a lot of economists in their program, and they've analyzed the cost of it and so forth. Here's a summary of the 9 project drawdown sectors. These 5 are geared towards reducing emissions of greenhouse gases, and things like solar and wind are in here, and changing the way we do agriculture here, making industry more efficient here, transportation, switching to electric vehicles, making buildings more efficient, all those kinds of things you would expect. So reducing emissions of greenhouse gases, protecting and enhancing the ability of the natural world to remove greenhouse gases from the atmosphere are associated with these 2 sectors. And this, by the way, correlates perfectly with the Rotary area focus called supporting the environment, because what we basically need to do is take care of the natural world, support the environment, because the natural world is our best sink of carbon dioxide in the atmosphere. Engineered sinks has to do with developing artificial means to remove greenhouse gases from the atmosphere. And finally, health and education has to do with limiting global population growth, which is an important part of the solution. Every soul that comes into the earth, into the world, brings with them a carbon footprint. And we are, we're at 7.5 billion people right now, and on track to probably hit about 11 billion by the end of the century. And holding that population down is a big part of the solution. I also highly recommend this book by Bill Gates, How to Avoid a Climate Disaster. You'll see a lot of overlap between the Bill Gates book and Project Drawdown, but Gates brings the perspective of a tech entrepreneur and just a businessman, and so he adds a lot to the discussion. He's a proponent of fourth generation nuclear power. I personally am not a proponent of nuclear power in general. The 2nd and 3rd generation nuclear power plants that are out there now have a lot of problems. The 4th generation plants that are under design now, a couple have been deployed. They do offer the possibility of significantly mitigating the problems with existing nuclear power plants. So indeed, nuclear power could be part of the solution, and Bill Gates talks about that quite a bit in his book there. So a few closing comments, and then we'll open it up to questions. There is an overwhelming international scientific consensus on the following 3 points. Point 1, over the past 120 years, the Earth has been warming and the climate has been changing at alarming rates. Point 2, global warming and the resulting climate change over the past 120 years have been driven almost exclusively by the Earth's greenhouse effect and the accumulation of greenhouse gases in the atmosphere caused by human activities. Number 3, without dramatic reduction in the emission of greenhouse gases into the atmosphere, the Earth will continue to warm and the climate will continue to change to the detriment of humankind. Stated simply, climate change is happening, humans are driving it, and it is not a good thing. So what are the actions you can take as an individual? Well, first of all, you can learn the basics of the science behind why our planet is warming and the climate is changing. And you've taken a step forward by suffering through my talk today, for sure. You can do what you can to reduce your carbon footprint while still living the life you want to live. You can use your position of leadership in the community to advocate for climate change. And I know you're all leaders, being part of Rotary. Whenever you have an opportunity to interact with other leaders in our community, be they political or otherwise, let them know that you want to see action taken on this issue. You can join an advocacy group such as the Citizens Climate Lobby and participate actively. And finally, you can vote for candidates who will address your concerns about climate change. So that's it. And now I'm going to stop the screen sharing and open it up to questions and discussion. Stop the share here.
I have a question, Jen. Can I proceed? Yeah, I read Bill Gates's book, and thank you for your presentation. And obviously, it's very consistent with it. But I wondered why Bill Gates and others aren't calling for a project on climate change. It seems like we're at such a desperate point, as we were in World War II with the need for atomic weapons, that it's time to put together that kind of a force, maybe internationally rather than nationally, as we did with the atomic bomb project. But it seems like a Manhattan Project around the ideas in Gates's book and the others you've described today is appropriate. And is anything like that occurring?
Yeah, that's a great question. And I have to say the answer is no, there is nothing like that occurring. There are a lot of individual efforts going on in different countries. There are some international efforts in specific areas that can be used to address climate change. Climate change is a very large interdisciplinary issue, no doubt about that. One of the things I'm particularly excited about right now is the prospect of nuclear fusion reactors. And there is a big international project based in France. It's called ITER, and the US is part of that. But also, I'm very happy to report that there has recently been a breakthrough in that area, and that breakthrough has happened in the US, which is really pleasant to hear. I was worried the US was falling behind in that, but MIT in the past year, in conjunction with a company back there, which is spin off of MIT, had a breakthrough in electromagnet technology, which gives them, they believe, a path forward to have a working nuclear fusion reactor by the year 2030 for demonstration purposes, producing electricity. And if they can make that work, then that could pretty quickly become a game changer around the world. We basically need to move to electrification of transportation and industry and so forth, but you've got to have a clean source of that electricity. And of course, we have wind and solar, and that's growing rapidly, and that's great. But nuclear fusion could be a game changer, and there is a pretty big international effort there. That's the kind of the closest thing I can think of to Manhattan Project style effort. But the thing about climate change is very broad, very interdisciplinary, it's also economically and politically controversial and difficult. So it's a tough issue.
Just a comment there. It seems like one of the first problems to be addressed is rallying people to understand that solving the issue is not going to be comfortable, and it's not going to be inexpensive, and it's going to disrupt our lifestyles. And until everybody in the world kind of comes around to that way of thinking, it's going to be hard to make progress, because I think a lot of people just think somebody else will take care of the problem for them, and I don't have to make a change myself.
Yeah, that's really true. And the other thing about it is, of course, it affects people around the world, very unevenly. Some of the people who are being impacted most strongly by climate change, for example, are people that are living in the small island nations of the Western tropical Pacific, Micronesia. The sea level is rising. It's actually rising faster there, quite a bit faster there than other parts of the world, and they're already very low ground. And so some of those countries are in jeopardy of losing their country, and yet they put only a very small fraction of CO2 into the atmosphere. There's no doubt about that. It's a tough sell. We've had the Kyoto Protocol, which was the first big international effort to curb climate change. That happened back in the 1990s. And it was a very good faith effort put forth by the United Nations Framework Convention on Climate Change, which came into effect in the early 90s. And it was an agreement that had teeth, because there were very specific penalties that would be, fines basically, that would go to countries if they didn't meet their targets. And that it fell apart very quickly. And quite frankly, a lot of it had to do with the fact the U.S. didn't step up. The U.S. signed the Kyoto Protocol in the late 90s during the Clinton administration, but the treaty was never ratified in the Senate. And when President Bush came in following Clinton, he declined to pursue it. And once it became apparent the rest of the world, the United States was not stepping up, they said, well, if the United States is not going to do it, we're not going to do it either. So it fell apart pretty quickly. And if you look at the plot of CO2 rising, there is no what's at all signature of the Kyoto Protocol. It just keeps rising. You would think there'd be an inflection point there. It's not, and nothing happened there. So the Paris Accord was the follow-on to that. And the Paris Accord in many ways is weaker than the Kyoto Protocol. It's kind of an honor system kind of thing. There's no penalties if you don't meet the targets. And we've already started falling behind the targets. Everyone is falling behind the targets. And of course, the US pulled out of the Paris Accord for 4 years. We're back in now. They just had the big meeting, COP26 in Scotland, you probably heard about, but not that much was accomplished there. So, it's hard to get it's hard to get people to do that. And the thing about climate change, it's a global problem, requires a global solution. We can't solve it here. Another country can't solve it. All the countries have to come together and solve it. And there are a lot of people and a lot of trends in the world that say, my country first. I don't really care about these global problems. I'm going to focus on what's the best for my country. Well, it's a global problem, requires a global solution. It does require sacrifice. It does require changing lifestyle, as Paul was saying. We're going to have to give up our gas guzzling SUVs, and we're going to have to change our diets, change the way we do agriculture, change the way we fly. All those kinds of things and change is hard. There's no doubt about that. The one good news here is the trend in people understanding that climate change is real, humans are causing it, it's a bad thing. That's increasing. 10 or 15 years ago, only about 40% of the US population would agree with those statements. Now it's about 60, 65. But there's an upper bound. It's probably about 70. It's probably never going to go above 70, but at least we're getting there. So I agree with you, Paul. It's a tough problem, and a lot of those issues, we just have to deal with it.
Mm-hmm. Mike, in the chat, Warren was wondering if you could put your YouTube information up, so he could get access to that. Is that okay?
Sure. I can just tell it to you. It's real easy. You can just go to YouTube and just search on Mike Clancy Climate. Just type in my name and then the word climate, and you'll see it's called Climate Change Matters with Mike Clancy. Climate Change Matters with Mike Clancy. We just type in my name and climate, and it'll come up. And there's a whole bunch of videos on there.
Awesome. So very cool. Thank you. And I have a question.
Yes.
So in terms of global contribution towards global warming, what countries are the leading countries that are causing global warming?
Exactly. China's number one by far.
Okay.
US is number 2, India is number 3, and then I think it's Russia, and then it kind of goes on down from there. China and the US together contribute about 40% of greenhouse gas emissions. Now, that's in total emissions. That's one way of looking at it. There's sort of 3 ways of looking at it. First, the total emissions. The answer is China by far. They're putting about twice as much as we are. The second way of looking at it is per capita. You take the total emissions of a country, divide by the number of people in that country. How much is each person's, contribution? Well, there's a lot of people in China. When you divide by the number of people in China, they drop way down the list. They become like a European country, and we're number 1. We have the highest per capita emissions of any country in the world. Now, we're followed pretty closely by Canada and Australia, but those 3 countries with US number 1 kind of stick out in per capita emissions. The average American puts about 17 tons of CO2 into the atmosphere per year. The average Californian puts about 9. So that's a good news story for California, but not such a good news story for the whole country. So those are the 2 ways of looking at it. But there's a third way of looking at it, and that is what country has put the most CO2 into the atmosphere since the beginning of the Industrial Revolution. In a way, you're thinking about what country has contributed the most to the problems we have right now. And guess what? The answer is the US by a pretty wide margin. We've put a lot of CO2 into the atmosphere. In the first half of the 20th century, burning fossil fuels was the right answer. We didn't have alternative sources of energy, and we needed to industrialize. We needed John D. Rockefeller. We needed Dale Carnegie. Otherwise, the world would be a very different place now, and we have a very different place in it. In the second half of the 20th century, not so much. In the first half of the 21st century, fossil fuels are definitely the wrong answer, and we need to get off them, but it's hard to do that. And just as Paul pointed out, but we really need to get off the burning of fossil fuels. What else?
Hey, Mike.
Yes.
There's a word that's a little terrifying that I never heard you mention, and that's runaway. Runaway.
Yeah. And sometimes there's the term tipping point. You hear that, you get to a point and it runs away. When people ask about that, I have to say, well, you have to talk about time scale.
Yeah.
You have to talk about time scale. Do we get to a point where it's run away and it's never going to come back? And the answer is no. If you're talking about geological time scales, there's pretty much nothing we can do to the Earth that the Earth can't recover from. Mm-hmm. What I often say is the humans are going to suffer. The Earth is going to be just fine. But you got to wait for millions of years.
Yeah.
You're going to have to wait for millions of years for the Earth to recover. It's the humans are going to be hurting. And indeed, one of the real concerns about runaway climate change, and you've probably heard about this, is the thawing of the permafrost. There's a huge amount of carbon stored in the permafrost, in Siberia and Canada and so forth.
Yeah.
And as the Earth's warming, that permafrost is already starting to thaw. And the carbon there, the microbes come alive as it thaws and it starts to rot the carbon. If it happens in the presence of oxygen, it releases CO2, which is bad enough. But if it happens in the presence of oxygen, you get CO2. In the absence of oxygen, you get methane, which is even worse. Yeah. Methane is about 20 times as powerful as CO2 on a ton by ton basis, And so the question is, where do you get to a point where it's runaway, where so much methane is reduced that the positive feedback effect is so strong that it's just, there's nothing we can do. It just gets really, really warm.
Yeah.
And no one really knows for sure. And I haven't seen many estimates. I've only seen actually one estimate, and that was about 5 degrees C of warming. And I'm pretty confident we're going to hold it below that level. So I think we'll be okay there. But there are many positive feedback loops. There are dozens of positive feedback loops that can amplify the warming. That's one of the most concerning ones. Yeah. And if we got to a point where that methane permafrost feedback kicked in, for all intents and purposes, and on the human time scale, it would appear as a runaway climate change.
Yeah, pretty scary.
Yes, for sure.
Yeah. I'm doing my part.
Excellent. Yeah, very good. We just put solar panels on our house this past summer, and we're looking to buy an electric vehicle, and so we're kind of doing the same thing.
Yeah, we have 5 kilowatts here, so.
Great. Same here.
Electric vehicles in the garage.
Oh, fantastic. That's great.
Well, actually, one's right behind me over here. It's 2 wheels. Doesn't everybody keep a motorcycle in their living room?
Well, thank you, Mike, so much for your time today. This was riveting, pretty sobering as well, but that's definitely absolutely need to hear. Yeah. This is a global problem, and thank you for providing insight on how we can hopefully fix it, or at least slow down the process.
Well, thank you so much for inviting me, and keep up the good work with Rotary, because you guys are right in there as part of the solution, definitely part of the solution. So keep it up.
Thank you so much. Yes, you too. Thank you. And thank you for bringing up all of these wonderful resources for us.
Okay.